Alright, this is a pre-calculus video going over how to solve absolute value equations. This was the last thing in that solving equation packet that we didn't go over. There's several different types of absolute value equations that we're going to talk about how to solve, and some of them are actually unsolvable. But for the most part, it's not too bad. There's a simple concept you understand. So let's start off with the most basic type of problem here, and that is the absolute value of x equals 8. Okay. Now understand that an absolute value means how far a number is from 0. So how far a value is from 0. So if we're looking at this, we're saying we don't know what value. What value are we talking about? But we do know that the particular value we're talking about, x, is 8 units from 0. So the idea is, if you think about it, how many numbers are 8 units from 0? Well, 8 is 8 units from 0. Or also, negative 8 is 8 units from 0. So that's the kind of cool idea here, is that the absolute value, the inside, could be positive, could be negative. But if you're telling me I'm 8 units from 0, again, it's a distance, so the answer is a distance. So this 8 is how far a number is from 0. So I could be 8, because that's 8 units from 0. I could be negative 8. That's 8 units from 0. So that's the most basic equation, and man, look how easy that is to solve. Okay, now we got to also take a look at a problem like this. The absolute value of x equals negative 8. Remember, the number over here, the number on the outside, is how far a value is away from 0. It's a distance, how far. And something we have to realize is that distance, or length, or distance, which is a measurement, cannot be negative. So this particular problem where we're telling you that there's a number out there that's negative 8 units from 0, that doesn't make sense, because this number, the number it equals, has to be a distance. So this one would have no solutions, because a distance cannot be negative. So when it's all said and done, absolute values have to equal a positive and a positive number only. Alright, so let's take a look at another one here. The absolute value of 2x minus 5 equals 11. So once again, we have the absolute value here. The inside is a number, and this mystery number is 11 units from 0. So this mystery number could be 11, because 11 is 11 units from 0, or that same mystery number could be negative 11, because negative 11 is also 11 units from 0. So notice how the inside, the 2x minus 5, stayed the same, but it could be 11 or it could be negative 11. There's no more absolute value bars. Once you kind of decipher that the fact there's two different equations you have to solve, they're gone. So add 5, so 2x could equal, let's see, 16. Divide by 2, so one answer is x equals 8. Add 5, I get 2x equals, let's see, negative 11 plus 5 is negative 6. Divide by 2, x equals negative 3. So either one of these numbers works. So if I plug in 8, 2 times 8 is 16. 16 minus 5 is 11. Oh yeah, 11 is 11 units from 0. Or plug in negative 3. 2 times negative 3 is negative 6. Negative 6 minus 5 is negative 11, which works, because negative 11 is also 11 units from 0. So let's take a look at another one here, a fourth problem, 3x plus 7, equals negative 4. So we're saying that some mystery number, we don't know what this mystery number is, we're going to call it 3x plus 4, but it has a distance of negative 4 from 0. Oh, but wait a minute. The distance, how far this mystery number is from 0, cannot be negative, because distance has to be positive. So when you have a negative, when you have an absolute value equaling a negative, that means there's no solution. So that cannot be solved. So that's kind of nice when that happens, okay? Now, be careful, because there's also absolute value problems where there's numbers left out. And I mean by this is I have 4 plus the absolute value of x plus 5 equals 7. So in order to solve this, I first have to get the absolute value part by itself. The absolute value part is this part right here, the part that has the bars around it. So that means that this 4 on the outside I have to move first. So subtract that 4 over first, and then I get the absolute value of x plus 5 equals 7 minus 4 is 3. Now I could start the thought process. This mystery number right here has to be 3 units away from 0. Well, I know that that mystery number could be 3, because 3 is 3 units away from 0. That's what absolute value says. Or that mystery number, x plus 5, could also be negative 3, because I know that negative 3 is also 3 units away from 0. So the idea is the inside, the absolute value, stays the same, x plus 5 x plus 5, but it could equal 3 or it could equal negative 3. So let's just solve this real quick. Subtract 5, excuse me, so I get negative 2. Subtract 5 over here, and I get negative 8. So there's my two solutions. Negative 2 plus 5 is 3. 3 is 3 units away from 0. Negative 8 plus 5 is negative 3, which is also 3 units away from 0. So it works. But of course, don't get fooled. Other problems could work. So we got the absolute value of x minus 2 minus 6 equals negative 4. So again, here's the absolute value. This is the number that I'm interested in, but I got this minus 6 right here. So don't start doing any kind of thinking about absolute value until you get this minus 6 over here. So I got the absolute value of x minus 2 equals, let's see, add that 6 over, and I get a negative 4 plus 6 would be 2. Right, I've added that 6 to cancel that 6 out. Now I could start thinking, and I have a positive here, so I'm telling me that the distance is 2. So this mystery number right here is 2 units away from 0. So that mystery number could be 2, because 2 is 2 units away from 0, or that mystery number could be negative 2. So again, notice the inside of the absolute value stays the same. You just got to think that it could be negative 2 or it could be positive 2. So solve. Add 2, I get x equals 0. Add 2, I get x equals, oh no, wait a minute. Add 2, this one, excuse me. If you add 2, you get a 4 there, apologize. Add 2 here, you would get a 0. So both of these are solutions. Let's just check them real quick. 4 minus 2 is 2. Hey, 2 is 2 units away from 0. Plug in 0. 0 minus 2 is negative 2, but that's okay because negative 2 is also 2 units away from 0. The main problem occurs in a problem like this right here where it's negative 4, where there's no number in the world that is negative 4 units away from 0, because how far you are away from 0 is a distance, and distance cannot be negative. All right, let's check out a couple more problems. Here's another neat one right here. X squared plus 8 equals 3. So again, the absolute value is already by itself, so don't have to worry about anything, trying to get rid of anything. It's already by itself. So I'm 3 units away from 0. So this is a mystery number right here, and that mystery number, x squared plus 8, could be 3, because 3 is 3 units away from 0. Or that mystery number, x squared plus 8, could also be negative 3, because if it was negative 3, then negative 3 is also 3 units away from 0. So let's solve these real quick. Subtract 8, and I get x squared. 3 minus 8 is negative 5. Square root. Uh-oh, wait a minute. If you recall, you cannot have negatives inside of square roots. So that does not exist. DNE does not exist, or no solution. So this particular value right here has no solutions. Let's try this one. Subtract 8, I get x squared equals negative 11. Square root. Uh-oh, wait a minute. Cannot have a negative inside of a square root, so that does not exist, which means overall there are no solutions. There is no way in the world that this mystery number could become 3. It just can't. This mystery number right here cannot become 3, which means there's no value that's going to create an answer for this mystery number that is 3 units away from 0. All right, let's check out one more. Just want to check out your understanding here. Make sure you're not missing anything. Here's another one right here. Absolute value of x plus 3 plus 7 equals 2. So remember, I have to think about this absolute value, but I got to get it isolated first. I got to get those absolute value bars by themselves. So this plus 7 has to go. So subtract 7. So I get x plus 3, the absolute value. 2 minus 7 is negative 5. And then I got to start thinking, this mystery number right here needs to be negative 5 units away from 0. But wait a minute, there's no number in the world that's negative 5 units away from 0, because how far you are away from 0 is a distance, and distance cannot be negative. So this particular problem has no solution because of that. So here's two different types of problems. This one started off working fine, but because of the square roots with negatives, you couldn't have a solution. All right, let's do another one here. And this last one we're going to do here is a really, really good one. Okay, the absolute value of x squared plus 7x equals 4x plus 10. So this is a little bit confusing because I got a mystery number on both sides. So this mystery number right here, right, is 4x plus 10 units from 0. Well, I don't even know what 4x plus 10 units from 0 is, but it doesn't mean I can't do the problem. Here's what I know, is that this mystery number, if it were equal to 4x plus 10, then I would have a number that was 4x plus 10 units away from 0. So if these two things were equal, I would work out. So that's one possibility. Or Remember, the inside always stays the same, x squared plus 7. If it was equal to the opposite of 4x plus 10, or the negative of that, then it would also have a solution that is that many units away from 0. So that would be negative 4x minus 10. You'd have to run the negative sign through there. So let's solve this first one here. I get x squared, bring over the 4x. That makes a 3x by subtracting it over. Subtract the 10. And I have a quadratic, and we have to factor this. So make sure this is good. We're going to get a chance to practice our factoring. X and x. Let's see, I need a 5 and a 2, plus 5 and a minus 2, because that's going to make the negative 10 in the back, and a 5x on the inside, and negative 2x is going to make the 3x. So one of these values must be 0. We've done this a lot recently. So let's see, subtract 5, I get x equals negative 5. Add 2, I get x equals 2. So there's some solutions right there. Now let's come over here and do this one. X squared, this time I'm going to add the 4x to get an 11x. I'm going to add the 10 to get a plus 10. Could be 0. And let's try to factor this guy here. I'm going to use a 5 and a 2 won't make an 11. Let's try a 10 and a 1, because if I do a 10 and a 1, I get a 10 on the back part there, and I also get a 10x and a 1x, which makes an 11x. So one of these values must be 0. X plus 10 could be 0, and x plus 1 could be 0. Subtract the 10, I get x equals negative 10. Subtract the 1, I get x equals negative 1. So I end up with 4 solutions to that particular problem. All right, so there we go. That's our absolute values. We're going to practice that in class or try them on the worksheet. Quick want to remind you that your big test over Chapter 1, is on Monday, September Monday, September 17th. So be ready for that in class. We'll do a little review. We'll talk about everything that's on the test so that you are good to go.